Welcome back to the workshop. So as you can see, I've pretty much stripped everything out. I decided let's just start again, then we know exactly where we're at. I've made a detailed wiring diagram. I've got numbered wires for all the different places where everything goes. So that's best thing to do, just start again, then we know exactly what we're doing. Also make it a little bit easier to debug in the future. So the only things I've kept, as you can see, I've stripped all this out. I've kept the, this is the reset. That's the reset button, so that was okay. I might as well just use that. We've also got over here, this is the potentiometer that goes up to the inverter up there, goes in the front panel. There's nothing wrong with that. I really quite like just having control on the front. I know a lot of people like to get the machine to control that, but it's all about preference at the end of the day, isn't it? So I kept that. And then the other thing I've kept so far is, so this is the cables that come in from the ancillaries, like I think we've got water pump, the lighting and things like that. So I'll decide how I'm going to work with those, but there's no point stripping that out because basically they're good to hear, and then I just need to know what to do with them there to plumb them back into these switches here. And if we pan you a little bit further up the cabinet, what we can see here, so these also come from the inverter. Basically this goes to, I think it's the forward and the common. Essentially if you just connect those two together, either just touch them manually or better still, we already have a relay in there to make that contact. That goes into the little front panel inside that, and that just is the run stop signal for the inverter there for the spindle motor. So kept that, there's nothing wrong with that, that's fine. We've got all the earths for the filter, for the shield, for the motor. I've kept all those, they're all together. Obviously the spindle comes in there, so that's kept. That's the filter for the inverter, I've kept that. 24 volt power supply, that'll do all the logic, so I've kept that. Obviously some of the little wires out there will have to be lengthened to go to their new homes, but that's fine. The 72 volt unit that runs the steppers, I've kept that, so we'll just have mains coming in, we've got the earth there, and then I'm just going to redo how the main power comes out there. I think it's actually more like 68 volts, and that will go down to this new DIN rail here. So I've just been reconfiguring this a little bit, so you may be able to see there that, well, first of all, that DIN rail's chopped in half, and then we've got another bit of conduit which I borrowed from down right at the bottom of this unit, which I wasn't really using, and that allows me to get a little bit better access to some of these cables up here and get a neater cable run. I didn't really need all the length of that anyway, so there's nothing lost by doing that. And then you might be able to see, if we just bring you in for a close-up just there, the DIN rails are actually on. I've turned some little, I think about 8mm spacers that sit behind that, so it brings the DIN rail out. So that's what that allows me to do. So if I've got a terminal on there and I want to come in to the top, or come out the top and get back into the conduit, there we are. I can actually go underneath the rail and back into the trunking, sorry. So it gives me that option, and that's all the way along, because there isn't really space to put another bit of conduit or trunking. So the other thing I've done is just clean and tidy this up, filled in some of these holes and masked it off and sprayed it as best I can. It's not perfect, but I don't think I really want to start again with the whole box. So I think, well, by the time it's all come together, a lot of it will be covered back over again. So we'll put this DIN rail back in. So because I've completely started again with this now, I've got a free choice on where I put stuff. So I'm going to put the master relay here, and then the spindle relay next to it, and then all those distribution blocks that I showed in the last video. The one in, I think it was 12 out, so there'll be 4 of those here, and then the AXBB unit will go here. Now I think I'm going to put it on little standoffs, and that gives me the option of, rather than going through here and through here, I can come under the unit and go back into this conduit down here at the bottom, because I've got all the main stuff coming through here, and I don't really want that too close to all the proximity and the switches. I mean, it should be reasonably noise immune, but it seems a bit more sensible just to route it under the box and go under here. So I'll put it on some little standoffs, and then that gives me the option of wiring it up in a couple of different ways. Now to do that, I'm going to use these little connectors here, so I've got 5 of each. Now I was going to use these because you'll notice they're brown and blue, and in the UK brown would be live and blue would be neutral, and I was going to use these further across as distribution blocks, just to have all the power come in to a pair, link them all together, and then have it go out to the different units. But there's actually not that much to power. This is powered separately from the contactor, and then there's only this one and the 5 volts, so I decided I'll just bring them out of the power supply and directly into that, rather than having just loads of these just for the sake of it. This does mean I've got some of these spare, so I'm going to use these because you can, as you can see in the top there, hopefully, not, hold on, let me get you just one. Right, as you can see, you've got two little holes in there, and what you can do is then, if you've got a few in a row, you can put those little connectors in there. Oop, stay focused. Put little connectors in and you can join them across to each other, so you can have one coming in and 5 coming out the bottom. We'll show you that in a minute, how that works. Right, let's get these set up. Where are they? Get that to focus. These are the DK 2.5, which, as you can see, you end up with some fairly small terminals that go in there. Now it is okay, you end up with some screws that may be on the small side, so I think if I did this again I'd probably go for the 4mm instead of the 2.5, but this will work, but you end up with them maybe being on the small side. Good news is you can get lots in, but I think I didn't need them to be kind of on the miniature side. You can get, obviously you'll see these ends are exposed. You can get blanking plates that go on the back as well. And I've just left a little bit of space, and I'm just going to put a sort of screw on blank at that end just to keep those nice and tidy. And that last one. Right, then we've got the fuses, and then the contactor. Okay, so we've got all our zeros. These will be the 68 volts, and these are the 3 fuse ones, and you can see how they work. So you just pull them out like that, and then there's a little 5 by 20mm fuse goes in there, instrumentation style. There you go, neat as that. So I've got to run the cables around there, under there, into the top, and then there'll be the little jumpers that jump the X and the A together. So that'll be one fuse. So the middle one will be Y, which will be this terminal, and then this one will be the Z. That will run the 2 motors via the 2 drivers, so that'll also have a little jumper in there as well. So I've got to make 3 little cables that go around here, underneath, come in the top, and then they can go down to the steppers. You'll also notice over here, these are the earths. This is what I had on the old system. It doesn't look very neat, does it? So I think what I'm going to do is strip that back to here. So we just have the one coming in there, and then we've got some jumpers in here. Now I've just run out of this 2.5 size, so when they come in I'll sort that out and put the little jumpers that join all those together. Right, so let's make up this little cable here. So for this bit we just need side cutters just to trim it to length. Then we've got wire strippers. I quite like this style. There's lots available, but this is quite nice. Put the wire in there, strip that off. And then this you may or may not have seen before. This is to crimp on these little ferrules here. So I'll show you that in action in a minute, but it's quite a neat little mechanism. It basically just squeezes down on all sides, finishes off the joint. So this is a bit out of the old control box. It's a perfect length, so just crop that to size. Strip that off. This wire's getting a bit thick, but no, that's worked okay. Some people say twist it, some people say don't. I don't really know whether it's a good idea to or not, but you certainly need something just to get that into the ferrule. So that's what it looks like. So you post it down there, and you want to make sure that you don't drop it. Yeah, and make sure that it's definitely gone all the way in. So if you look down the end there, you may or may not be able to see. You don't want it kind of bunched up and hardly in at all, because that's likely to come out. So without dropping it, sometimes worth getting a little bit of a grip on there. That's held lightly in there now, and then you can kind of do it that way. Make sure it's fully home, and then always give it a pull test, because if it comes off, obviously it was no good. Right, there's our piece. So we need a couple more like that, and then we'll go and fit them into the cabinet. So we've got all three wired in now, and the next thing to go on is the contactor. So this is what that looks like. So this is like a kind of industrial relay, and the way it works is you've got at the top there L1, L2 and L3. That's where the main feed comes in, so that might be live, neutral and earth, or whatever the three things you want to switch. And then at the bottom, that's where the outputs are, T1, T2, T3. When it switches, it just directly connects each of those to each other, so it joins those lines together basically. So in here and out the bottom, obviously they're separate from each other, but it's joining them together. And then the way it joins them together is you've got A1, A2. If you apply 24 volts, in this case, across here, and hold that 24 volts, it switches and it joins those together and runs whatever it is you want to run. In my case, it's going to run the toroid up there, the power supply. So as long as you hold that 24 volts there, it will run. As soon as you break that, it switches off and it breaks the connection. Now in this unit as well, we've also got 22 and 21. There's terminals there that allow you to detect whether it's definitely switched across, if it's switched on or switched off. It's kind of a logic system. And the reason you might want to have that is if, just in case this is like burnt out and it's burnt the contacts together, and you don't know if it's jammed, and it's basically a way of monitoring and make sure it's doing what you think it's doing. And you could run that to some kind of e-stop trip out if you wanted to, just as a way of sort of being doubly safe. But I'm not going to use this very much. It gets very low duty cycles, so I'm not going to make use of that function, but it's there should you want to. So now I'm going to install this upside down like I did before, because the power comes in the bottom and then it's convenient to have it coming out the top to the supply. Makes no difference really, but that's how that works. And then at the back it's DIN rail mounted, and on this one you've got like just a little spring loaded tab just at the bottom there. So the way that goes on is you hook it over the top. Sorry, no, it'll be the bottom in this case, upside down. Push against that tab, click it over, and that's it, it's on. That's pretty secure. Right, let's get that. In fact, I want to move that across a bit, don't I? If I can move it, hopefully. There we are. Right, let's get that wired in next. Doesn't matter the order of these really, as long as obviously you match whatever you've got coming in to whatever you want to go out again. Oh, that was good. Oh, it's so awkward with the camera in the way. Always make sure everything is really tight, because if you come back and have to debug it, it can be a long time. Okay. Tight? Yep. So I'm just putting in all the earth terminals. These are what they call the star earth. So all the earths will come together at this point, and they can communicate to each other through the DIN rail, because at the bottom of these are special terminal blocks. You see they've got these metal kind of claws that grab onto that. And the way it works is as you tighten that screw in there, it pulls that down, and these little sort of metal teeth in the corner pull in and grip it onto the rail. So to get it on, you need to make sure you back that screw out enough, and then make sure you get them the right way around, just so the colours look nice more than anything else. Okay, that's it's wide enough to go around, and then just do the screw up. And that should be all the earths I need, because I can come in through the bottom here and through the top, and because I've backed it off, you can see we've got those 8mm spacers. I've actually got a gap behind, so I can run cables in from underneath, come in the top, and whatever we need to do. So next up we're going to fit these miniature circuit breakers. As the name suggests, they break the circuit for whatever you got connected in here. So you put your live and neutral in here, and then it breaks or makes the connection to the live or neutral coming out the top. And then you've got this 2-pole off at the moment, and then on. And this particular unit is a D10, so it's rated at 10 amps, and then the D is the curves, the sort of rapidness or slowness that it will respond. Now I'm running this, or powering the toroid or transformer up there. So when you turn these on, basically you just get an instantaneous direct short, so you have a huge spike in the current, and then it takes a very short time for it to build up the magnetic field and then oppose that and settle down. But essentially you get that massive inrush spike. So the D rating on here allows it to cope with that sudden inrush, so that's what we're going to fit. And of course these are DIN rail compatible. These are quite nice because the way it kind of goes on is a little bit of a two-stage system. It's just a nice, really good quality kind of fit you get with this style. Alright, so we'll put that one first. So again, it hooks over, and then you just push these in. That's solid. And there we are. Keep those off for now. Now the last ones to do on this row are all the earths. So we've got earths from here, we've got earth from the shield, earth from the filter, so we'll just group all those together. Now they're a different type to the ones I got over there, but it's the same idea. I'll just show you one of them. So with this type, you don't tighten it up, but the spring-loaded mechanism that you use to get them onto the DIN rail is part of the metal hook system that goes on there. So I kind of like those a little bit better, but I had a load of these spare and they're fine. That's what I had here before, so I'll just reuse those. So let's get those mounted. So I've just got all my auxiliary earths wired in there. So it's the earth from the filter, earth from the screen, all the cable, spindle and everything. They go onto the DIN rail, so they are technically all earthed all together. And then I've just got a little spacer piece in there, and they look like this. There's a couple of different types, but basically what happens is when you turn the screw in there, it just pulls those jaws down and it clamps onto the rail. It doesn't do anything other than just kind of group them all together and keep them neat. The other thing I think you might be able to see there, I've just put the end plate on there. You can get these cover plates that go on the end just to stop you having live terminals exposed. Although for earth it's probably not too much problem, but it looks a bit neater. So you just turn these until hopefully you feel it start to grab. Oh yeah, we got it. Yeah, looks good. And then the other things you can see in there, I've got the two little fuse terminals, same type as we had over on the other side. So this is for the 5-volt supply, so this is my little 5-volt power supply. So as you can see, I've pre-wired that in because it's a bit awkward to get those in there. So that'll go into this MCB here. And then the feed for the 5 volts to come into one of these. That'll be our 5-volt fuse in there. And then the 24 volt, when we get that hooked up, there'll be a 24 volt feed that will go through this fuse and then out to all the control system. So I've basically got my 5 and 24 volts fused. That's the 5 volt DIN rail mounted power supply. So I'll have mains power coming in the top when this contactor's on, or this MCB is on, sorry, and then it will put 5 volts at the bottom through that fuse there. Okay, before we go too much further, the little jumpers have come in for the 2.5 Dinkles that will fit into there. So I've just remade the 0 volt line there from the power supply. So to make that work, I just need to connect them together. Now I do have some, so these are the 2 ways that come in. I do also have some 3 ways in order, which would be better because I just put 3 at the top and 3 at the bottom, but for now this will also work. I'll put the 2 in there. I'll put 2 in that one. And that will share power or the 0 return from all the drivers back into that single cable. Okay, like all wiring, that took a little bit longer than expected, but I'm pretty pleased with it. Yeah, it looks nice. So we've got our 72 volts DC coming down through the fuses there, and then they go into the little distribution blocks, and then we'll jumper together, and then we get the feed down to each of the drivers down here. And speaking of fuses, the fuses have arrived. So we've got our 5 amp fuses there, and our 10 amp fuse. These are 5x20 instrumentation style, and we'll put the 10 amp ones in where we've got 2 drivers to fuse, and then the 5 amp is for the single axis. So you just open them up like that, put the fuse in the side, and then yeah, there's our 10 amp in there, and the centre one that just feeds one driver, that one gets 5 amps. I'll label all this up so I know what I'm supposed to be putting in what. Okay, so now we've got our stepper driver power wired up. We need to do some of the logic systems here, the 24 volts, so we'll put those on next. Okay, so now we're going to put the relay up, the master relay. So this is the bit that controls the logic, the safety side. Now I've been using these for a little while and I'm pretty pleased with them. They're DIN rail mounted, they're pretty cheap. I think this is a 14 way, so you've got plenty of ins and outs. The only thing to say is obviously this wouldn't pass industrial rating. It hasn't got forced contacts to make sure if one of the contacts welds shut, then you don't get an indication on the others, and you know, it just hasn't got all the safety features and monitors that those have got. But that being said, pretty low duty cycle, DIY environment, I've been pretty pleased. If you do get a fault with it, you can just take this top piece out and just swap it out for another one without even changing the wiring. So we'll drop that in. That's our master. Next one up similar, although I didn't need quite that many ways. I think I probably could have got away with an 8-pole here. I have, I bulk ordered them, so it's no problem. So this is the spindle inhibit relay, and if the master relay is not tripped or not energized, then you can't operate the spindle. So it's kind of a safety feature for that. Drop that on next. Then we've got these nice little distribution blocks that I showed you in the last video. So I found these on eBay. I'm pretty impressed so far. Hopefully they'll do the job. So we've got one in there, that's where the main comes in, and then we've got up to 12 coming out the other end. I think I said earlier in the last video that might be 100 amps, 250 volts. Actually I think I read somewhere it's the other way around, but either way, plenty good enough for what we want, so we'll drop 4 of those on. I'll give myself a little bit of room from these, sure get your hands in. Drop that one maybe there. And these are a bit fiddly to get in, seems to remember. Let's try wire one. So again, because the camera's in the way, so I'm going to have to reach around it a bit. Come on. Oh man, that's tight, isn't it? Alright. First thing I don't like about them, they're a bit tight to get on. I'll tell you what we'll do. Just cheat and slide them on. I'm sure if I pushed harder it would go, but they're about £8 each, so I don't really want to break it. Just mean getting them off the service might be a bit of a pain, but yeah, that's a bit of an easier way. I think it's because, yeah, they haven't actually got a little spring mechanism in there. It's basically the spring-loaded nature of the plastic, which is a bit probably on the stiff side. But hopefully they'll work. Bit of spare there in case we need something. Maybe just space those a bit. And then once all that's done, we can finally get the little control unit, the AXBB Ethernet motion controller sorted out, and a nice little space for it just here. Then once we've got that in, we've got our 24 volts and 5 volts power to go in. We've got our outputs down here. These are step and direction. The 01, that's the charge pump. We'll use that as part of the safety system. And then all these inputs and out, or the inputs over here, they'll be for all the proximity and limits and so on, and the e-stop. So before I sign off, a little bit of good news, exciting news. Now you might remember in the last video I mentioned Jazz CNC. They're a CNC custom machine builder. Now I knew they supplied some of the parts you see here. There's some switchgear and steppers, drivers, that kind of thing. I didn't really know what they provided exactly, because until now they haven't had a website. However, that has all changed. They've got this website up and running. Go and check it out. I'll put the link down in the description below. You can see a link to it also on the screen here. Got all sorts in there, including the custom machines that I mentioned before, but also drivers, servos, all the control systems, the sort of industrial control buttons, start, stop, relays, proximity sensors, anything you'd really want to need really to build a cabinet like this. So go and have a look at that and have a look at the custom machines. And on that note, thank you very much for watching, and see you next time.